Hello fellow problem solvers, so today we're going to be doing a problem from the Nigerian Senior Mathematics Olympiad round 3 from 2021. I suggest you try this problem out for a minimum of 10 minutes, ideally 30-45 minutes, but not more than an hour and 20 minutes. If on the other hand you'd like to go along with us, I suggest you take a preliminary look of 5 to 10 minutes. So now, let's begin. Okay, so this is our problem. And the first idea when you have, so p is a prime and n is a natural number. So the first idea I have when I have primes and just one prime and then some natural number polynomial is, let me just put the p's on one side. This is p to the fifth times p plus 1. And let me put the n's on the other side. So this was going to be n times n to the power of 4 minus n squared plus n minus 1. And now here's where I invite you to pause for 3 minutes and push the problem further. So the next idea is sort of when you have a prime, you have a times b is c times d. The question is, which factors do they share? And now the thing about c and d, like n and n to the 4th minus n squared plus n minus 1, is if some number, say it's a prime number, if q divides n and q divides n to the power of 4 minus n squared plus n minus 1, from here, we know that then q divides n squared, n to the 3, n to the 4. And now if you subtract n squared, subtract n to the 4th, add n squared, subtract n, then from here you will get that q divides 1, which is impossible for a prime. Now in our context, it means that p divides n, or p divides n to the power of 4 minus n squared plus n minus 1. And not only p, but all the p's divide just one of these two. And now this means that p to the 5th divides n, or p to the 5th divides this. And here I invite you to take another 5 to 10 minutes and figure out if you can push this and solve the problem. So this case, p to the 5th divides n, immediately falls because this implies that case 1, p to the 5th divides n. This implies n is greater than or equal to p to the power of 5. And now n times n to the power of 4 minus n squared plus n minus 1 is greater than or equal to p to the 5 times p to the 10th times p to the 10th minus 1 plus p to the 5th minus 1. And then this is greater than or equal to p to the 5th times, we just need this to be greater than or equal to p minus 1. We can just make it p times p minus 1 plus 1. I don't know if equality never really holds. Let's make it strictly, and then this is greater than or equal to p to the 5th times p minus 1. I mean, again, it's strictly greater than this, and this is a contradiction. So this case falls apart, which means we need to look at the second case, which is p to the 5th divides this thing, n to the 4th minus n squared plus n minus 1. And now here with this case, I invite you to take another 5 to 15 minutes. And the thing here is, look at this up here. We're saying this divides this. Now, what about p plus 1 and n? If p plus 1 was to divide n, then we would have n is greater than or equal to p plus 1, and then this whole thing would be greater than or equal to this, i.e. we would have equality, so that means n, because it has nothing in common with p to the power of 5, it doesn't have p in it, it means that n divides p plus 1. So that means this implies n divides p plus 1. And now what do we have? Well, p is greater than or equal to n minus 1. And now look at this. So I invite you to take 3 to 5 minutes and see if you can finish this case. And the answer is, well, now we have p to the 5th is less than or equal to n to the 4th minus n squared plus n minus 1. This is equal to n squared times n minus 1, n plus 1 plus n minus 1. And then this is, by this, less than or equal to p times n squared n plus 1 plus 1. And now we can use n plus 1 is less than or equal to p plus 2, and is less than or equal to p plus 1. And now we have here, this is less than or equal to p times what? So for n squared, we have p plus 1 squared times p plus 2 plus 1. And now, well, now we need to move on to the place where we are going to be evaluating these two things. So here, we have this implies p to the fifth is less than or equal to p times p plus 1 squared times p plus 2 plus 1. And now this here implies that p to the fourth is less than or equal to p plus 1 squared times p plus 2 plus 1. And now how do we bound this? This means p to the fourth. This is p squared plus 2p plus 1. P plus 2 plus 1, so it's going to be p to the third plus 2p squared, 2p, 4p squared, and now we have p 4 times, once, 5 times, and we have 2 free plus free. So now we have this. And now this is going to be strictly increased, like this function. This is if this side is going to be greater than or equal. This we just need to figure out when. So we have that for p is equal to 5. What do we have? This is 5 times 5 times 5 times. So this is 25 times 25, 625. Okay, so for 5 we're good. So this implies p is less than or equal to 3. And now from here, what about p is equal to 3? Then we have 81 less than or equal to, what is this going to be? 81, 27 plus 4 times 9. This is 36 plus 5 times plus 15 plus 3. Does this make it? So this is 30. Oh my god, this is 51. Wow, this makes it. So p equals 3 is a valid contender. And now we need to check two cases. Namely, we need to check case 1, like subcase. Subcase 1 is p is equal to 3. Now this implies that because we have equality, I think we will be nearly, actually let's see what it implies. So n divides 4, and now this here implies, maybe given our constraints, actually let's look at the other thing as well. So we have 200 and, oh yeah, we're going to be solving this quite quickly. This 81. No, this divides n to the fourth minus n squared plus n minus 1. So n equals 1. It succeeds. I guess. Oh, look, it actually succeeds. Huh. Succeeds in the divisibility, but not in the actual solution. So n equals 2 gives us, this divides 16 minus 8 plus 2 minus 1. Does not succeed, and n equals 4. Will it succeed or not? And I think n equals 4 does succeed, because this is then 16 times 15, n squared times n squared minus 1 plus 15, right? Or no, plus 3. Made a mistake in the algebra. And this is 16 plus 180 plus 3, 33, and we get that p is equal to 3. N is equal to 4, we actually get an equality. This actually does succeed. And now the second case, case 2, p is equal to 2. Then we have n divides 3, n equal to 1 fails, and n is equal to 3. What do we get? We get 2 to the 6th plus 2 to the 5th plus 3 to the 3rd plus 3 is 3 to the 5th plus 3 squared. Now what does this mean? Well, when we do the math, we get 64 plus 32 plus 27 plus 3 is equal to 243 plus 9. This fails. So the only solution is that Pn is equal to what? 3 and 4. And that's the only solution. And as always, thanks for problem solving.